Okay, so we're going to do the process on this particular quadratic equation to put it into vertex form. So let's remind ourselves of what vertex form is. So f of x equals a times x minus h squared plus k. So that's the form we're trying to get it in. A is the multiplier. H comma k are the vertex, are the points for the vertex. Okay, so we've got to make this look like that. So we're looking for a perfect square so that we can change these first two terms to become that perfect square. But we don't want the a inside that perfect square, so we have to factor that out. So that's what we're going to do first. Okay, so when we factored out the negative 2, we had x squared left over and a negative 12x, because remember we're taking a negative 2, we're just dividing 24x by negative 2, because now that it's written like this, remember we could distribute the negative 2 back into each of these terms, and we get this exact same thing. So we have not changed the value, we've just rearranged it to try to get it into this form. Okay, so now in order to get a square, perfect square here, we need to add another term. We need an extra value in here. And right now we can tell what that value is, because remember, if we take the b value, negative 12, and divide it by 2, we'll get a negative 6. So we have negative 6, and then we're just going to take that and square it to find out what the other part of this term needs to be in order to turn it into a perfect square. So negative 6 squared is just 36. So we're going to add 36 to this. Now notice that we haven't done anything to the negative 67 because we just need to keep that going. We haven't manipulated that at all because we haven't changed anything there. However, over here we have, this value has been changed because we changed it by adding 36. Now, it's not an arbitrary addition of 36. We chose 36 very particularly because it's half of b squared so that we can turn this into a perfect square. Because remember now, this actually can be rewritten to be x minus 6 times x minus 6. Because when we FOIL it, we see that we get the x squared. Our firsts give us the x squared. Our outsides, x times negative 6, gives us a negative 6x. Our insides, negative 6 times x, gives us a negative 6x. And combined, that gives us that negative 12x. And then our last terms, our negative 6 times negative 6, gives us that positive 36. Okay, so by adding that 36, we get our perfect square, but we can't just say, well, let's just add 36 to our equation. We can't just do that without adjusting out here. But we also have to remember that it's not just a 36 that we changed, because it's all being multiplied by this negative 2. So what we really changed on this by adding this 36 is we really contributed a negative 72 to it. Now, how did I get negative 72? Well, I just did 36 times negative 2. 36 times 2, this is a times, I should probably put times a negative 2. When we multiply 36 times 2, we get 72, but a positive times a negative gives us a negative 72. So we've changed this side by negative 72, which means we've got to change this side by a positive 72. So we have to add 72 over there to keep the equation the same. We cannot change the value of this equation. So now all I've done here is I've simply simplified this equation. I already showed that this was going to be x minus 6 squared, and we can't take away that negative 2 because that we have that in our original equation, so that negative 2 stays there. And then I just simplified these two terms, negative 67 plus 72 gives us a positive 5. And now we are exactly in the form that we needed it in. We have our a, which is negative 2, and remember the a helps us to determine the stretch or compression as well as its orientation along over the x-axis. So since a is negative, it's rotated over the x-axis, excuse me, not rotated, it's reflected over the x-axis, so it's going to be upside down. And it's also going to be stretched. It has a vertical stretch of 2, so it's going to stretch it long along the vertical axis. We also have our vertex. We can find our vertex because H and K are our vertex. So our vertex ends up being 6, 5. So we can specify our vertex now, and with all of this information, we can quickly graph it because we can plot our vertex. We know that we're going upside down because the a is negative, and we also know that we're stretching it by 2 because the absolute value of a is 2. So here's the graph of this equation. You'll notice that we have the vertex at 6, 5, just like we expected. It's upside down because it has been reflected over the x-axis. And you'll notice that if we go 1 point over from our vertex, 1 squared would be 1. But because we have a multiplier of 2, it's actually a 0.2 away. And then if we go 2 away from the vertex, 2 squared would be 4, which would put us right here. But actually, because we have a multiplier of 2, we have to go to 8 to get onto our graph. We can do the same thing to the other side. If we go the other side by 1, 1 squared is 1, which would get us here, but we have a multiplier of 2, so it actually puts our point there to graph it. If we go another point so that we're 2 over from the vertex, 2 squared is 4, which would put us here if it didn't have the multiplier of 2. But since it does, we have to go to 8. Which is a point right there. And just by having that vertex form, we can easily graph this.